Good morning, folks. Today we are going to look at thermochemistry, one of the important topic in AP chemistry. And I want you to pay attention closely. This could be beneficial to you, especially at this time when the exam is fast approaching. Get your pencil, your periodic table, and your calculator ready to do some exercise. All right?
Thermochemistry refers to the study of heat flow or heat energy in a chemical reaction. Heat, energy. In the study of thermochemistry, the chemical energy is transformed into heat energy during a chemical reaction. Units of energy. The SI unit of energy is kilogram meter squared per second squared. This was given the name joule. Thus, the SI unit of energy is joule. 1 joule equals 1 kilogram meter squared per second squared. 1,000 joules equals 1 kilojoule.
Remember this. The most common unit of energy is calorie. 1 calorie equals
4.184 joules.
All right, at the same time here, you can easily convert your calories to joules. If you consume a bottle of soda and it says 5 calories of energy have been consumed, you can easily multiply that by 4.184 to know the amount of joules you've consumed, so that you know the amount of energy in that bottle of soda.
Heat energy is what flows into or out of the system because of a difference in temperature between the system and its surroundings. System is a part of the universe on which we focus our attention. For example, a beaker of water is in contact with the hot plate. The water in the beaker is the system.
surrounding is the rest of the universe with which the exchange of heat energy occurs. For example, the hot plate and the beaker holding the water is the surrounding. For practical purposes, only those materials in close contact with the
System.
are called surroundings.
The direction of heat flow must be studied from the system's viewpoint. In this example, when the hot plate is turned on, the water gets hot. In other words, the water temperature increases. Here, the heat flows from the
Surroundings.
into the system. When the heat flows from the
Surroundings
into the system, the process is called
endothermic.
And when you have endothermic reaction, the system cools down. That means if you touch the container becomes colder because the heat goes into the system. The heat goes to the system, so the system absorbs the temperature, and then the surrounding becomes colder. That's when you see that the body of the conical flask or test tube becomes cooler. And that is endothermic reaction.
heat is expressed by the symbol Q. Q, in common terms, is the quantity of heat. Q is expressed in joules or kilojoules.
For an endothermic process, Q is greater than 0, or Q is positive.
When the beaker of hot water is left out by itself, then the heat, Q, flows from the system to the.
Surroundings.
When the heat flows from the system to the
Surroundings.
The process is called exothermic.
And this is when the temperature of the container becomes hot or warm because heat was dissipating to the surrounding. It's like exit. So the heat is given out of the system, and that makes the test tube or the beaker hotter or warmer than the usual temperature it started with. And at this time, the change of heat is going to be a negative sign.
For an exothermic process, Q is less than 0 or Q is negative. Magnitude of Q. The magnitude of Q is directly proportional to the temperature change. Temperature change equals T final minus T initial equals delta T. Q is proportional to delta T, or Q equals C delta T. C is the heat capacity of the system expressed in joules per degree Celsius.
And remember that C is a constant. Anytime you change a proportional sign to equal sign, you get a constant in replacement. So this C is a constant. Every substance has their own specific heat capacity, which is going to be given to you in any question.
Heat capacity, C, is defined as the amount of heat required to raise the temperature of the system by 1 degree Celsius. Also, the magnitude of Q is proportional to the mass of the system. Q is proportional to mass. Combine these two equations. Q is proportional to mass times delta T. Or Q equals
C.
times mass times delta T.
C is the specific heat of the system, expressed in joules per gram per degree Celsius. Specific heat, C, is defined as the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. This equation is often written as
Q equals M
C
delta T. Example: the specific heat of iron is 0.466 joules per gram per degree Celsius. How much heat is given off by a 50.0 gram sample of iron when it cools from 80.0 degrees Celsius to 50.0 degrees Celsius? M equals 50.0 grams.
C equals 0.466 joules per gram per degree Celsius.
Delta T equals T final minus T initial equals 50.0 degrees Celsius minus 80.0 degrees Celsius equals minus 30.0 degrees Celsius.
All right, I want to come in here. You have to look at the questions very carefully. If you read the question, it says when it cools from 80.0 degrees Celsius to 50.0 degrees Celsius, meaning that this is your initial. That is where you started from. That means from. Anytime you see from, that is the initial. And to is the final. That is your final destination. It's like moving from Forest Park to your house. Your initial destination was Forest Park. That is from. And then your final destination is your home, which is to. All right?
Q equals equals minus 699 joules.
Example. Chromium has a specific heat of 0.449 joules per gram per degree Celsius. If 5.00 grams of chromium at 23.0 degrees Celsius absorbs 60.5 joules of heat, calculate the final temperature. M equals 5.00 grams. C equals 0.449 joules per gram per degree Celsius. Q equals 60.5 joules. Delta T equals T final minus T initial equals T final minus 23.0 degrees Celsius.
All right, remember our formula is Q equals to MC delta T. Your Q was given in this question to be 60.5 joules. So that Q comes here. Equals to your mass, which is 5 grams. Your C is this, and your T is your final minus initial. And you're looking for final temperature. From the question, it says calculate the final temperature. So we're now looking for this T final, which is going to be your final temperature on the question.
T final equals 49.9 degrees Celsius.
All right, this should be straightforward. You have to pause the video to make sure you know how to calculate this area. It can be tricky sometimes.
Example. The specific heat of copper is 0.382 joules per gram per degree Celsius. How much heat is given off by a 12.0 gram sample of copper when it cools from 125 degrees Celsius to 40.0 degrees Celsius?
All right, here you need to supply your answers to what is your mass, what is your C, what is your delta T from the question. All right, I'll give you 10 seconds, or you can also pause this video if you're watching it at your own time to supply these answers before you step forward. Right, these are the values for mass. The C and delta T is negative 85. That means that temperature was, this is the final, 40, because it says store. So 40 minus 125 will give you negative 85. Don't make a mistake of subtracting 40 from 125, which will give you a positive sign. All right. So when you solve this, you should get your answer right in here. That is 12 times 0.382 times negative 85. Your answer should be negative. If your answer is negative, what type of reaction is that? Is it exothermic or endothermic? All right, if you say exothermic, you're correct, because when you have a negative temperature as your Q, that reaction is exothermic. If the answer to the Q is positive value, that means greater than 0, then the answer, your reaction is endothermic.
Example. Iron has a specific heat of 0.446 joules per gram per degree Celsius. A 30.0 gram sample of iron absorbs 107.04 joules of heat, and its temperature rises to 68 degrees Celsius. Calculate the initial temperature of the iron sample.
All right, this is another interactive section. So go ahead, supply the mass C and Q. You should get 30, 0.446, and 107.04. And then your T final minus T initial is going to be what? Remember, its temperature rises to 68. So that should be T final minus initial. T final minus initial. That means you're looking for initial. So your final temperature was 68 because it says the temperature rises to 68. So that means it's going to be 68 minus T initial because you're looking for initial temperature. You should get T final 68 minus T initial, and therefore your initial will be 68 minus T. That is, after you calculated your temperature and stuff like that, you should type in your answer right here.
Calorimetry. The measurement of heat flow is performed in a device called a calorimeter. The calorimeter usually contains water and/or other materials of known heat capacity, C. The walls of the calorimeter are insulated. Thus, there is no exchange of heat energy with the air outside the calorimeter. The chemical reaction occurs in the calorimeter. Hence, the heat is contained within the calorimeter. The heat flow for the chemical reaction is Q reaction equals negative Q calorimeter. For an exothermic reaction, Q reaction is less than 0. Thus, Q calorimeter would be positive.
All right, in this case, this is like a computer, garbage in, garbage out. Whatever you put into the system gives it back to you after processing. So the Q reaction, that is the heat given into the system, is the heat absorbed by the calorimeter and its contents. So in this case, we're talking about calorimeter alone. So if Q, the heat given into the calorimeter is 100 joules, the heat absorbed by calorimeter is going to be 100 joules. All right, so that's why you have positive here, negative here. Because under normal circumstance, they're supposed to be equal. Because law of conservation of mass, right? For an exothermic reaction, Q reaction is less than 0. So when this heat is coming in, it's absorbed by the calorimeter, and when calorimeter is giving out the heat, it's going to be the same heat it absorbed initially.
For an endothermic reaction, Q reaction is greater than 0. Hence, Q calorimeter would be negative.
Q calorimeter equals C calorimeter times delta T. If the calorimeter contains water, then C calorimeter is equal to M water times
C water.
M water equals mass of water in grams.
C water equals specific heat of water equals 4.18 joules per gram per degree Celsius.
Thus, Q calorimeter equals M water times 4.18 joules per gram per degree Celsius times delta T. If the calorimeter does not contain water, then Q reaction equals negative C calorimeter times delta T. C calorimeter equals heat capacity of the calorimeter. Example: when 2.00 grams of magnesium chloride is added to 65.0 grams of water in a calorimeter, it dissolves according to the reaction. The temperature rises from 25.00 degrees Celsius to 29.87 degrees Celsius. Calculate Q for the reaction system. M water equals 65.0 grams. Delta T equals T final minus T initial equals 29.87 degrees Celsius minus 25.00 degrees Celsius equals 4.87 degrees Celsius. Q reaction equals negative 1.32 times 10 to the third joules.
Example: 7.00 milliliters of C4H10O is burned in a calorimeter. The temperature rises from 25.0 degrees Celsius to 39.7 degrees Celsius.
C calorimeter equals 10.34 kilojoules per degree Celsius.
A. Calculate Q for the calorimeter.
Delta T equals T final minus T initial equals 39.7 degrees Celsius minus 25.0 degrees Celsius equals 14.7 degrees Celsius. Q calorimeter equals 152 kilojoules.
B. Calculate Q when 7.00 milliliters is burned. Q reaction equals negative 152 kilojoules.
C. Calculate Q when 1 mole of C4H10O is burned. Molar mass of C4H10O equals 74.0 grams per mole. Density equals mass divided by volume equals mass equals density times volume equals 0.714 grams per milliliter.
All right, there's a need for me to talk about this a little bit. Now, here, you need to get your mass of the substance, but you are not given the mass. You are given the volume. The volume was 7 milliliters. But you know the molar mass of this. And you are given the density. Now, when you are given something like this, then you should know behind your mind that, okay, I was given density. Definitely, I need to get my mass from the formula of density, which is density is mass over volume. Since I know my volume, I know my density, I can easily get my the mass. All right?
Times 7.00 milliliters equals 5.00 grams. When 5.00 grams of C4H10O is burnt, Q reaction equals negative 152 kilojoules. Thus, when 74.0 grams per mole of C4H10O is burnt, Q reaction equals 74.0 grams per mole divided by 5.00 grams times negative 152 kilojoules equals negative 2.25 times 10 to the third kilojoules per mole.
All right, here you can see that the answer to B is what we're using here. You got negative 152 when 7 mole of that substance is burned equals to this heat. Now remember I told you if you don't remember how to do number B or letter B, but you know how to find letter C, since the answer you got in letter B is going to be used in letter C, you can just make up this answer. Just write an imaginary number, 75, 80, 90, 100. Just an assumption. Then you can now use that value to solve this problem. Your final answer might be wrong, though, because you didn't get the correct answer in B. But you are going to get some points on this step. All right, remember that. If you don't know B and you know how to solve C, and you know that the answer you got in B is going to be used to answer letter C, you can make up any number to represent the answer for B and then use it on letter C question. Then you still get some points. All right, don't just lose out completely. Don't be knocked out because you can't answer B and then you stop and you quit. No, continue with the C. If you know you can answer C and you don't have the answer to B, which is going to be used for C, then go ahead, make up a number and then use it as your answer for B, and then go ahead and plug in the numbers. So Q reaction for that would be negative 2.25 times 10 to the third power.
Example: when 20.0 grams of ammonium nitrate is added to 125.0 grams of water in a calorimeter, the temperature falls from 20.0 degrees Celsius to 9.9 degrees Celsius. Calculate Q for the reaction.
All right, look for the mass of water from the question. Delta T, T final minus T initial. Go ahead and solve that from the question. These are the way you're supposed to set up your problems. Get your data. The data you need to solve the problems are very crucial. Get them ready before you move on so that you can easily pick them from that section. So these are the values from the question right here. Then your Q reaction will be negative 125 times 4.18 specific capacity of water, joules per grams per degree Celsius, multiplied by negative 10.1 degrees Celsius. Then you type in your answer right here inside the box.
.0 milliliters of a substance is burned in a calorimeter. The temperature rises from 22.0 degrees Celsius to 37.5 degrees Celsius.
C calorimeter
Equals 8.50 kilojoules per degree Celsius. A. Calculate Q for the calorimeter. Delta T equals T final minus T initial equals
So your Q reaction will be 58.0 over 4 0 times negative 132. We'll write your answer in the box. That'll be 1.9, negative 1.9. That's an exothermic reaction.
Heat flow in a calorimeter
The specific heat, C,
of a substance can be determined accurately by measuring temperature changes that occur when heat is transferred from the substance to a known quantity of water at constant pressure P.
C water equals 4.18 joules per gram per degree Celsius. C water equals 4.18 joules per gram per Kelvin. The specific heat values are the same when expressed as degrees Celsius or Kelvin.
Delta T equals change in temperature. The change in temperature will be the same when expressed as degrees Celsius or Kelvin. The sum of heat changes within a given system is 0. Thus, Q substance plus Q water equals 0. Q substance equals mass substance times
C substance
times delta T. Delta T equals T final minus T initial. Similarly, Q water equals mass water times
4.18 joules per gram per degree Celsius
times quantity T final minus T initial. Hence, plus equals 0. Example. A calorimeter contains 125 grams of water, and its initial temperature was 21.0 degrees Celsius. A 35.0 gram metal was heated to 99.8 degrees Celsius and dropped into the calorimeter. The final temperature of water and metal is 23.1 degrees Celsius. Calculate the specific heat of the metal. Mass substance equals 35.0 grams. T final equals 23.1 degrees Celsius minus T initial equals 99.8 degrees Celsius equals negative 76.7 degrees Celsius.
Right, take your time to go over it once again. You're using this initiative. Remember this mass of water here, substance plus mass of the substance given to you, calorimeter, and the water equals to 0. So that means the two must add up to be 0. And that was why you're not trying to substitute long substitution right here at the bottom. So pause the video and we'll work it out step by step.
Mass water equals 125 grams.
4.18 joules per gram per degree Celsius.
T final equals 23.1 degrees Celsius minus T initial equals 21.0 degrees Celsius equals 2.1 degrees Celsius. Negative 2,684.5 times
C substance
plus 1,097.25 equals 0.
Remember, if you solve this right here, that's what you're going to get here. When you solve this, This is what you're going to get, and everything equals to 0. Remember, all these values were taken from the question right here. Mass of calorimeter, 125 grams of water, and its initial temperature was this. The 35 grams of mirror was heated to 98.8 degrees, 99.8 degrees, and dropped into calorimeter. The final temperature of water, remember the initial temperature of water was this, final temperature of water was that. So that is how they come together as, getting all these values right there. So take them step by step. Just follow the step.
C substance equals 0.41 joules per gram per degree Celsius.
Click on the table. It gives the specific heat values of several substances.
All right, these are the specific capacities of all the substances. This will be given to you in the question. Since you are going to do a virtual exam, so I would advise you get a data table that has all this, probably one of your NIMSI super problems paper or any of the NIMSI question paper has all these formulas and probably this heat capacity. If it's not there, it's going to be given to you in the question. Or you can have your textbook handy.
Example. A calorimeter contains 85 grams of water and its initial temperature was 26.0 degrees Celsius. A 28.0 gram metal was heated to 75.5 degrees Celsius and dropped into the calorimeter. The final temperature of water and metal is 27.1 degrees Celsius. Calculate the specific heat of metal.
All right, this is going to be our parting question. I want you to solve this problem. Send it to me for credits. And then probably we can talk about that in classroom. Please try to solve this problem on your own, because this could be a likely question you come across again in your AP exams. All right, this is another question, question number 2 for you to practice. A calorimeter contains 100 grams of water and its initial temperature was 22 degrees Celsius. 35 grams of a mirror of specific capacity, 2.25 joules per grams per degree Celsius, was heated and dropped into the calorimeter. The final temperature is 26.50 degrees Celsius. Calculate the initial temperature of the mirror. So this is the second question I want you to try out. So I'm going to stop on those 2 questions for you to practice. I will let you see the solutions in the classroom. As soon as you send them to me, then we'll talk about that. I'll probably post the response and the answers to that question after I've gotten your responses. All right, so ladies and gentlemen, this is where we're going to stop for today. And I want you to click subscription button after watching this video. If you're watching it on your own, please subscribe so that more videos will be you'll be alerted and whenever I post another video, either on this topic or any other topic. Thank you for watching. Have a nice day, everybody.